And then I'm going to put Discord on the right. There we go. I am now recording. Very cool. Hi, everybody. What made me change it from Substance Painter? The thing is that Substance Painter is I mean, it's an Adobe program, and I mean, for starters, that's already a problem. Like, an educational license is cool and all, but I don't like furthering this idea that like you gotta pay a ton for these programs. There's a lot of great open source solutions out there. Now, beyond that, texturing is out of scope for like a game jam. It's not entirely out of scope, but like if you're hand texturing a model for a game jam, like it, I mean, that's like high level. Like it better be a week long game jam or something. Like it's like you're not doing that for a 48-hour jam. And like if you texture one thing and then everything else is solid colors, it looks weird. So if you texture one thing, you got to texture everything. And then like texturing is just this like very, diligent process. It's exhausting. So yeah, that's what I was kind of cautious about.
All right.
Yeah, I didn't want to point people in the direction of skills that aren't immediately useful for the like complete beginners here. Even though there's not that many complete beginners that like actually pull up to the live stream, we've got some complete beginners that will hopefully, watch these videos and meet up sometime later in the week. Uh yeah. Real quick, sweet potato, what school? Oh, and he's gone.
Um,
Godspeed. Well, all right. Cool. Great. Without further ado, I'm going to share uh, my screen, and then I'm going to um, yeah, I'm gonna move Discord right over, and then I'm going to turn on my webcam and turn it off over here. I'm gonna get started with shaders. Let me make sure stream quality is good. And let me make sure that the camera is pulling. Whoa. Yeah. Give me like 2 seconds, guys, to make some minor adjustments real quick. Oh gosh. Okay. Let's do 200, 100, 100. There we go. Cool. um, okay. All right. All right. So shaders. All right. Is everyone ready? We good to go? Yeah.
yeah.
Yeah. All right. Cool. So here we go. Introduction to shaders. Brief introduction. Who am I? I'm Michael. You guys already know that. Some people on YouTube might not. I like shaders. I'm also senior at UF. In that order. Shaders first. CS major second. I love shaders. I'm in a computational photography class right now that I had no idea would be image processing. Like I should have had some idea, but I didn't. And yeah, it's kind of awesome. I kind of love it. So um, yeah, it's definitely part of school. But today we're going to be doing Unreal Engine a little bit. We're also going to be doing a little bit of Blender because I mean, you apply materials. We're going to get into the vocabulary of that later. Shaders, materials, you apply them to a model. So I'm going to give you guys a Blender file, and we're going to sort of set it up and then put it in Unreal Engine. Yeah, here's the plan. Speed. We're gonna move really fast. So yeah, today shaders. There's a lot of content. This PowerPoint is 160 slides, of which around 70 or 80 slides are I've blacked them out so that you guys can go and like check them out on your own time if you want to, because they cover like a little bit on texturing and a little bit on there's a tutorial at the end that's like a very step-by-step process on making an ocean shader, a very simple one, but a pretty good looking ocean shader with like displacement and stuff. So what are we doing today? I'm going to show you what we'll be making. We're going to do the basics of materials. We're gonna skim over textures and tessellation, but we'll try to cover things like snow, projection, and like master materials. And I'm not going to get into waves, ocean, and grass, but this was stuff that I could do at a separate time, but might not be able to squeeze it in. Okay, so yeah, the PowerPoint's going to be available. This is actually today. Even though I'm giving 3 little workshops, it's the only one that I have a full PowerPoint for. The other ones are going to be a little bit faster for the people that come in, but this one's the more intense one, I'd say. So, um, yeah, you're here because of Wargames. I don't think anyone here is from FIT or FAU, but that's okay. If you were, that would have been really cool, but that's okay. The idea with these workshops, just a reminder, because some of the feedback from last time was people were like overwhelmed because they came to like all 3 of them, and they were like, "Oh God, do I have to show up for 6 hours of like?" No, you don't. Pick a role, right? If you're an artist, come to the art themed ones. If you're a technical artist, come to the technical art themed ones. You don't need to stick around here for the next 4 to 6 hours. That's egregious. I wouldn't do that. I will because I'm giving the lectures, but in the workshops and all that. But you shouldn't. So, anyways, I'm also going to give you guys some flowcharts at the end of this that give you like an idea of how to organize your knowledge for shaders. Because I love shaders. I put a lot of effort into this. Like shaders are awesome, and there's a lot to learn in them. And there's sort of this tree of knowledge that you can combine to make your way around and like navigate what you need to understand in order to become really good at shaders. Shaders. What's a shader? Right. So this is an image from Unreal Engine. This is from a project I did a long time ago, several years. And the grass here is an example. Is really what I'm focusing on. But there's multiple shaders in this image. I mean, the sky here is being it's a bunch of colors, right? We got clouds and like the blue sky in the background, and these are being generated programmatically and projected onto a hemisphere that sits above our world, the sky sphere. I'm sure some of you guys have played like Gary's Mod or I don't know, some random game and like glitched out of the world only to fall through the level and like see the sky in the distance being like a giant hemisphere. It's got a shader on it, and the shader describes the properties of the surface. The grass here, all of it has a shader on it. Shaders are sort of just they're what describe the properties of a surface when we're talking about game engines. But in reality, a shader is much more simple than that. It's just a little bit of code that runs on your graphics card, and it does so in parallel. That's what makes them special. It's like small, usually small, sometimes they can be really big, chunks of code that are executed in parallel per pixel, per point on the surface, per something. But they're executed in a massively parallel fashion on your graphics card. Here's that same grass from a different angle. I think it looks very pretty. This is one of the shaders that I'm really proud of. It's got some really cool properties. The light is shining through it. The shading and the height varies. And this is what that grass shader looks like in Unreal Engine. It's very simple. It's very simple. Here's that same grass except colored to look UFy, well, blue and orange, because there was like dry clumps and wet clumps, and I made the wet clumps taller and slightly different color. This is what happens when I actually play with the colors. Yeah, so this surface right here is using a shader to create this sort of effect of like rocks that seamlessly transition into dirt. This is part of texturing, but the transition here and the way that it all reacts to the light of the environment is defined by the shader. Here's water. The surface of water in video games is a shader. So I hope this is sort of giving you some idea of what it is that we call a shader. And yeah, I mean, here's another surface of the ground here. This one has tessellation, so the surface is being subdivided into like a billion little points, and then those points are being displaced up and down based on a height map, and that height map makes it look all stone and pebbly. This is another environment that I made. Oh my god, this brings back memories. This is like 10, 11 years ago, and the water here is Unreal Engine 4's like default water. The trees, the way that their leaves are waving around in the wind, motion can be done with shaders. This is water at the surface near the edge of an island, near a shore. These waves are a big shader. This over here is cool little hologram with like a sine wave that's kind of making it displace and has this cool holographic pattern on it. Shader. This is the shader for the shoreline waves. So it can look a little complicated, but it's not. Frankly, the terrain itself is a giant shader that says if the surface is below a certain height, make it sand. Otherwise, if a surface has a certain slope, make it gray. But if it's pointing upwards, make it green. And just like that, we've colored our entire terrain without doing a hint of manual labor. We've just typed in a little bit of code that says, based on the angle of a surface and based on its altitude, give it a certain color or certain properties. Shaders can be used with like pixel art and stuff. On the right is a brick wall. You can't really tell that it's pixels, but it is pixel art. And it has a normal map. We'll talk about what that is, but it lets you do these like really cool shadow effects. On the left, we have some armor of a soldier. And as the snow builds up, it fills in the cracks first and gradually spreads outwards. And you get this snowy transition of what it looks like when someone freezes. So shaders. Shaders are able to create all of these cool things. We'll get into the details of what exactly they are. We're not going to be making the textures today. We're just going to be applying the shaders to surfaces. But textures are an important part of shaders or materials. Some of you have worked with Unity before. Some of you have worked with Unreal Engine before. What Unity calls a shader, Unreal calls a material. What Unreal calls a material instance, Unity calls a material. Bit of a, just in case anyone's coming from Unity, you should know this. It's a little weird, but yeah, we're going to be focusing on Unreal vocabulary from here on out. So when you hear me say material instance or material, that's what I'm saying. I prefer Unreal's vocabulary because it sort of has this subtle nod to the fact that a material is much more than just a shader. And I'll get into exactly what that means in a second. So let's dive a little bit deeper. Let's get into what that actually means. Graphics cards. We all know what a graphics card is, right? Hopefully. What's so magical about graphics cards? They let you do all sorts of stuff in parallel, massively in parallel. Matrix multiplication, convolution. Oh, convolution's a pretty linear process, actually, but image processing. Executing simple code in a really parallel fashion. You can take a for loop, right, that iterates 10 times, like say for pixel in image, and instead of doing it as a for loop, you just do a billion threads that are assigned to like 3 pixels each, and they all complete in like nanoseconds. So yeah, what does parallelizing tasks look like in code? It depends. In C++, you work with threads. In Java, you use some fancier threading stuff. They have like a whole architecture built for it. It's a little safer than threads. Godot calls it a shader material. That's funny, Dion. Anyways, sorry. GPU magic. What the hell does this look like in GPUs? There's a problem. It depends on your graphics card. So this over here is the CEO of NVIDIA. This is Steve Jobs over here. They have something in common. They like walled gardens. So what's a walled garden, right? Like when they, create a product that is like only accessible with their technology. So NVIDIA is pretty dominant in the market right now. And they have a programming language, more of a library that sits on top of C++. It's called CUDA, and it lets you talk to their graphics cards. However, programs that rely on CUDA, they don't work on AMD cards. So how is it that some of you in the audience today are on an AMD-based computer, or maybe just you have an integrated graphics card and you're still able to run Unreal Engine? How is Unreal Engine diversifying its code base so that it runs on AMD, it runs on NVIDIA, it runs on integrated graphics? How is anything doing that? How's your web browser doing that when you go to the Develop website? So a lot of programs rely on CUDA, but how do we get around the walled garden? With abstraction. This is an NVIDIA card. NVIDIA drivers let it use CUDA. AMD drivers let AMD cards use ROCm or OpenCL. Intel graphics cards can also use these, I believe. But it's really hard to use all these different things. These are some complaints that I found just on Reddit real quick when I was trying to figure out how to use ROCm in combination with TensorFlow because my friend had a really overpowered AMD card and he didn't want to buy an NVIDIA card. It's terrible. It's difficult. Don't think too much. Just get the CUDA-enabled GPU. Drivers can be a gigantic B word. Avoid ROCm. Setup is a nightmare. So there's this magical layer of intermediate processing. This is all theory, but I think you guys should know this, so bear with me here. There's these things right here. Vulkan, WebGL, DirectX 12. What are these? These are graphics libraries. And it gets better because Vulkan, WebGL, and DirectX all speak in the same language. GLSL, HLSL, they all use the same language. So by the transitive property, no matter what graphics card you've got, no matter whatever, as long as it's passing through either Vulkan or WebGL or DirectX, at some point you're writing code in either GLSL or HLSL, and that's the magical language of parallelizing things on the graphics card. GLSL or HLSL. You don't have to use CUDA. You can for fancier lower level applications like HyperGator, the supercomputer that we have on the UF campus, uses CUDA behind the scenes for some of its applications. Like if you, well, you as a researcher, you do some AI, you write the AI in PyTorch or TensorFlow, and those Python libraries are usually optimized for CUDA, so they run on NVIDIA technology extremely well. But you can do higher level tasks in GLSL and HLSL. This is where rendering and graphics things happen. You can also use these coding languages to do more compute tasks that aren't like graphics oriented. Why do those logos all look the same? What's the difference between Vulkan and WebGL? Yeah, the reason these guys look the same is that the same company, same sort of like I think it's some open source like graphics consortium puts them together. They're part of the same group. So anyways, yeah, graphics and compute APIs, massively compatible, focused on 3D graphics, but they can also accelerate compute tasks like machine learning. Chronos, yeah, Chronos Group, something like that. Yeah, you're right, Dion. That's the name of the company. They abstract away the features of lower level APIs, but not that badly. Like you can still do really low level interesting things with GLSL or HLSL. They're less performant, barely. They're easy to use, and they standardize the language for a GPU. They use GLSL or HLSL. GPU is a graphics card for those of you that, yeah. The other thing is that they do separate GPU and CPU code. If you were writing your code in purely CUDA, you could do this magic where some threads go on the graphics card, some threads go on your CPU, but you can't do that with GLSL and HLSL. These execute purely on the graphics card. So shaders are what power all sorts of different things. They work in your browser. When you open up Google Maps and you render out this like beautiful 3D like render of your environment, Google Maps is using your graphics card for that. Unreal Engine has all sorts of shaders that run it that do 3D rendering. This is a scene from Doom on the left that has its own rendering engine. So let's get started. I'm gonna give you a glimpse of Shader Toy. We're not gonna write any code here. I just want you to see what a shader actually looks like at the lowest level. But we're not gonna write any code, I promise. Shader Toy is a really cool tool. It runs in your web browser and it lets you just do all sorts of things. You can make shaders with it. You can write code in GLSL, and yeah, it's awesome. This is a shader, and this is it. It's this little function right here says spit out this texture and also make a move around. This is what the output looks like. It's a bunch of pixels. Shaders talk in 0 to 1 values. They don't talk in 0 to 255. So you can see kind of this is all these black pixels are 0, 0, 0 all around, but like down here in this brick area, we got all these like random numbers. And shaders, it's just a function. It's just a function. Like there's not that much more. Dear God. So that's what a shader is. It's a function of a couple of different properties. The properties being various inputs. These are some of the inputs up here. Things like the resolution of the screen, or the current time, or where the mouse position is. These are the things that are exposed to Shader Toy, but we actually have way more to work with in Unreal Engine. However, materials are like shaders that are sandwiched between other shaders. So Unreal Engine is rendering your three-dimensional environment. This renderer is real-time rendering, has a lot of things going on. It might be shooting out ray traces for doing like RTX and lumen magic. It's doing all this crazy nanite magic. At the end of the day, however, it gets back all the geometry of the world. It gets things like the lighting, and you end up with this image But this image initially is just this idea of like where those pixels hit on the surface of different objects. They don't know what the color of those objects are yet. They don't know what the properties of those objects are. That's where materials come in. So there's already a shader, potentially multiple shaders, multiple little programs that are running in concert to produce a render. And the material is just the shader that is ascribed to the surface of an object and is sandwiched between the renderer, which is just a billion other shaders that are, running sequentially. So yeah, I hope that like it shoots out a bunch of rays. It finds, okay, this pixel hit this object, and then it executes the code related to the surface of the object. That's where the materials come in. So today we're going to be working on materials. So now you got the theory. You got like a vague idea of the theory. That's all I wanted to leave you for. Also, I'm going to take off these goofy glasses. They've not been doing me too well. Hold on. All right. I know you guys can't see me, but the recording sure can, and the glasses were starting to hurt. So, chunks of code that tell Unreal Engine what to show for each pixel of the surface that our player sees. Materials sound like a shader. They're almost shaders. Yeah. They describe higher level properties. They don't just describe the pure color that's going to come out of a material. They describe things like, is it shiny? Is it metallic? Does it glow? Does it move around? They can displace the surface. They can do all sorts of things. And they are applied to the faces of a mesh. So every mesh, every object that you model in like Blender, in any program, is composed of a bunch of faces. And those faces can have a single material. There's one material per face. So your whole object could have one material that's applied to all the faces. There could be like 5 different materials. If I was making a building, which we're going to do later, you might have a glass material for the windows. You might have a awning material for awnings and umbrellas that makes them wave around. So yeah, let's look at Unreal Engine and let's see what making a material actually looks like in Unreal Engine. I'm gonna launch Unreal right now. You guys should launch Unreal as well, and just let it launch in the background, and I'll move ahead for now. But making a material in Unreal Engine is done in the same way that you make anything. You right-click in the content browser, which is at the bottom of your screen, and you click on material. Materials are green. It's like one of the main things in Unreal. Let me spin up a new project over here. You can, for the project settings, you can set it to be Blueprint, C++, ray tracing on, ray tracing off. It does not matter. And if you have performance issues, I'll show you what you can do to fix that momentarily. But yeah, I'm gonna move forward for a second while Unreal Engine boots up, and then we'll come back to this and actually like work through it together. How do you program in a material in Unreal Engine? You double click the material. That's all you do. So once you double click a material, you end up on a screen that looks something like this. So I just made a material in Unreal Engine. It says, here's Unreal, right? And when you double click the material, you end up with this screen right here. This is where the magic happens. So the first thing that we see here is a bunch of outputs right here. All these outputs. These are the properties of the surface that we're going to be able to describe. The base color, metallicity, specular, roughness, anisotropy, emissive color, normal tangent, world position, pixel depth, all sorts of properties. We're going to ignore all of these bottom ones right here. They don't really matter. For now, they're higher level things. Refraction is like when you're working with transparent materials. Like there's a lot of cool stuff you can do here. We're not going to focus on those. Before we move on, real quick, just to reiterate, every point on the surface of an object, every pixel on your screen, usually, you think of colors as 1 to 255. We're talking 0 to 1. Okay, 0 to 1. And that's true for color, but other values can actually go in the negatives. They can go to infinity. For example, how bright a surface is in Unreal Engine is handled by the emissive output. I think we saw it a second right here. Emissive color right here. So the emissive output can go all the way to like 1,000,000, 1,000,000,000,000. Like you plug in any value you want, and what that's going to do is it's going to make that pixel glow. Like every pixel of the surface of the object that our screen intersects with is going to get this crazy glowing effect applied to it. It also, in the latest versions of Unreal Engine, that's to say Unreal Engine 5, emissive surfaces actually emit light into the environment. They don't just fake a glow onto your screen because of the way that Lumen works. So that's kind of cool. But yeah, the last thing that we have to learn before we get a little hands-on here is how data is stored in materials. The way that you pass around data in a material is with vectors, and in a sense, vector fields, but it's primarily vectors. Scalars and vectors, right? There's a two-dimensional vector, a one-dimensional vector. You can also call that a scalar. Red vector, green vector. This is a little play on the old Dr. Seuss shenanigans, right? One fish, two fish, but we don't have blue vectors. I mean, we do. I guess that would be the third number in a vector. Excuse me. Traditionally, a vector is a magnitude and a direction, right? It's an arrow. It can also be a color. In materials, you can make it mean whatever you want. At the end of the day, it's just a data structure, right? Vectors can be directions. Here's a two-dimensional vector. It's got an X and a Y component. How do you describe a color? 3 numbers. How do you describe a two-dimensional direction? X and Y component. What about a three-dimensional direction? X, Y, Z. If I give you RGB 001, what color is that? That's blue, right? 101, it's going to be purple. And it's going to have a magnitude of more than 1, right? It's going to be like square root of 2. What directions are those? Blue is the same as straight up in Unreal Engine because we treat Z as the up vector. Purple would be 45 degrees with a ground plane. So yeah, just a little bit about vectors. So back to the node editor. Let's actually give our material color. How do we define color? 3 numbers. What also has 3 numbers? A 3-dimensional vector. Unreal Engine would call that a 3 vector. That's also how they're called in GLSL or HLSL. You do 3 vec. So let's go ahead and color our material. The way that you breathe vectors into existence in the material editor is you can right click and you can start typing 3 vector and move your hands off of the mouse. Not a great move. Just hold the 3 key, right? Hold down 3 on your keyboard and then you click. And that spawns in a 3 vector. If I hold down 2 and I click, 2-dimensional vector. If I hold down 1 and I click, we get scalars or 1-dimensional vectors. So I'm just clicking around right now while I have 1 held down. That's how that works. So let's go ahead, and if you're here with me, I'll give you guys a second to catch up. Literally just 3, click. We have a 3D vector. You can also right click and just type in 3 vector, constant 3 vector, whatever. You plug in this white output, which is to say all 3 channels of the 3 vector. And you plug that into base color. You hit save and apply, and now our material is black. Nothing has changed. But we change this X value to a 1. It's red now. Nice. Very nice. We have colored our surface. For game jam purposes, you're like 90% of the way there. Like in a game jam, you're speeding around. You have more important things to worry about than the aesthetics of your environment. You maybe make a nice grass shader or something, but for the most part, you're going to color your buildings with some really simple materials, and that's going to be it. So, or your character or whatever, it's going to be solid colors. You'll also notice there's this sort of panel down here and to the left. This panel, when you click on nothing, gives you all sorts of really important properties of the material. But when you click on a node, it gives you the details about that node. So we can see the same values right here. If I click this this color, I get a color wheel, and once I hit OK there, that updates. Save and apply. You have to hit save up here for it to update. And we're back in our Unreal Engine world. If if I click on the terrain right here, the terrain is broken up into all these chunks. And furthermore, if I click on the details panel on the bottom right, you got to check the box landscape material. You can actually drag this in, and now this surface is going to be driven by our material. So we've replaced the default landscape material, which is this gray grid. I know it looks kind of tan. That's because of the color of the sun. but we're replacing this gray grid with this pink shader. Very cool. Very cool. Very simple. All right. So what have we done? We gave our material some color. You connect it to base color. You hit save. Bada beam, bada boom. Looking at this, guys, feel free to unmute yourself for a second. Let's talk about what we're seeing on the screen. Tell me something. Someone describe the surface that we're looking at right here. Anyone? Speak up. 5 points. Gryffindor, whatever school.
Metallic.
Metallic. That's cut into the chase. There's yeah, metallic. It's kind of shiny, right?
With a bit of roughness added to it.
Yeah, a little bit of roughness. That's right. What about here? We're going from left to right here. What are we looking at? It's getting rougher. It's getting rougher. That's what's going on. Let's talk about these metallic and roughness. So, metallic and roughness are, base color. We plug in a three-dimensional vector to base color, right? Metallic and roughness is going to be a one-dimensional vector. So, how rough is a material? How metallic is a material? We're not asking what color roughness, right? That's not what you ask. So yeah, it's determined by a single number. It's not some two-dimensional property or three-dimensional property. How do you add single number outputs to the node editor? You just hold one and click. One vector is also called a scalar. That's all. Here's a nice little graph of roughness and metallicity. You'll notice that black is 0, white is 1. So these are super metallic and completely shiny, not at all rough. This is fully metallic and fully rough. This is not at all metallic, not at all rough. Something you guys should know is that metallic is actually binary in real life. So in real life, the optical properties of materials that are conductive are fundamentally different than materials that are resistors, not conductive. So dielectrics and like really conductive materials have very different optical properties. So with this in mind, metallic, it's even easier. Just set it to either 1 or 0. Something is either metallic or it isn't. Like wood is not metallic. Plastic is not metallic. Something that's metally, like conductive, metallic. Just set it to a value of 1 and then play with the roughness. This is like a fact. Yes, it's a 0 to 1 value, but you don't need to work with that 0 to 1 value. So let's go ahead and do that. I'm going to hold 1. I'm going to click twice. Plug a value into metallic. Plug a value into roughness. I'm going to make the metallic value be 1. Roughness value is 0. Now we get this beautiful pink chrome. Look back over here. Nice. Great. It's working. Very cool. The reason we're able to see the reflections on here is due to screen space reflections to a large extent, but the actual sky in the background is, I think, being driven by software ray tracing on Lumen. I don't think I have hardware ray tracing enabled, but if I did, my graphics card would be bouncing those rays into the clouds that we're seeing up above. So that's pretty cool. But yeah, we're seeing reflections now. These are driven by a screen space effect. Notice the second that the mountains go out of view, they disappear from the reflection. But yeah, this is a metallic surface. If I make it completely rough and still metallic, well, what are we looking at now? Now we see this kind of like matte metallic car paint surface. Pretty cool. Okay. All right. Moving along. Don't mind that little applying to Blue Origin, little Jeff Bezos. All right, what do we know so far? Colors are defined by 3 numbers. It's called a 3-vector. N-dimensional vectors, N numbers. Vectors represent directions or color. We'll see how they can be used to represent directions in a moment. A base color material takes in 3 numbers and controls color. Metallic input and roughness take a single number and they handle metallicity and roughness. That's what we've covered. Let's pause for a moment and let's take a look at Blender. And let's take a look at how objects go from Blender to Unreal Engine and have multiple materials on their surface. So I've got a building right here in Blender. I'm going to give this to you guys in a moment. But here, let me just make it just make it look a little bit better. Turn on the shadows and the cavity mapping. There we go. The Devil Up Cafe. What a nice little building right here. Very cool. This building is a mesh. The umbrellas and things are separate objects. So here's the building as its own individual chunk of geometry. I haven't bothered making the back of it very aesthetic. Oh, yeah, sure, William. William asked for details on the dielectrics. I'm going to try to do that in a little bit. Not right now, but I will. Okay, so the Devil Up Cafe. Lovely. On the right in Blender, you have this little tab down here in the, I think this is the details, properties panel. And so this is where you add new materials. Materials don't translate from Blender to Unreal Engine very well. The reason why is because Blender is, I mean, it does real-time rendering, yes, but it also does like 3D rendering with like photons and like actual full-on like path tracing is what you would call this when you're bouncing actual rays into it. And those rays are built around BSDFs. When you make a new material over here, you get all these things that are called BSDFs. BSDFs are bidirectional scattering distribution functions. They describe the probability that a photon is going to bounce off a surface in a specific manner. So that's why Blender's, like, it doesn't translate to Unreal Engine. The only thing that translates, the only thing that you have to worry about is creating, think of this as a way of creating slots in Blender. You're saying these surfaces are going to be this material slot. That surface is going to be another material slot. So it's a way of just grouping together surfaces that are going to share the same material. While we're here, let's go ahead and I'm going to just demonstrate this really quick. I'm going to have this first material be like building, and I'm going to make it green just so that we can, see what that is. I'm actually going to make it this sort of concrete, kind of yellow, maybe white. Nice. Then I'm going to make another material. I'm going to click new. Doesn't really matter. And in edit mode, I am going to call this windows. And I'm going to assign this. I'm going to select the faces that I want. So this face, that. Yeah, that's it. And I'm going to click Windows and click Assign. And make that green. And now, you see, we have assigned this material to these surfaces. In Unreal Engine, we're going to replace these properties with our own shader, our own material. But let me also select the text over here. This is going to be like a neon sign. So I'm going to go ahead and name it neon. And I'm going to make it pink for now. All that matters is that we're creating a... Did I still have the windows selected? Oh, I did. Damn it. Wait. Okay. Hold on. Let's select the windows again. See, it's easy to make mistakes. Windows, green. There we go. So now we got 3 different materials here. We'll do another one. We'll do awning red. This is an example of how you would be doing this during a game jam. In order to move quickly, you would make a lot of materials for a single object, and you would use the materials to actually do the sort of coloring. This is not good practice. Good practice is actually texturing the object. If it's just like a bunch of solid colors, you texture the object. You don't really bother about materials like this. But yeah, we're going to call this awning red. Make that red. How's that look? Nice. And then I'm going to go ahead and select all of these faces right here. Deselect these guys. Deselect these guys. And I'm going to deselect the red ones. There we go. And this is going to be the awning white. I'm also going to make one more material for the doorway. Cool. Let's also just do this as red. There we go. Awning red. Cool. How we looking? Nice. She's coming together. Oh, forgot. Missed a piece. Awning red. There we go. Great. The Devil Up Cafe. Beautiful. Let's go ahead and make these doors be like brown, maybe. Door. Assign. Cool. All right. Now, magic. Here we go. We could probably make this thing be like an awning as well. I'm sorry. It is important to cover everything here. So let's just control plus minus. There we go. Awning red. There we go. All right. I like that as white. We'll make this white. Okay, these colors don't matter, but I'm thinking about how they're going to look in Unreal Engine. So I'm going to export this now. I'm going to do File, Export, FBX, send it to my desktop, test model.fbx, and call it Mesh. I think I have a standard object. There we go. Export. I've saved it. Oh, she's lagging. All right, cool. Save, close Blender, and let's open up Unreal Engine just to show you how these things translate over. Where's Unreal? There's Unreal. File, import, import. Am I clowning? I am clowning. I think oh, there it is. Import. Desktop. Test model. Open. Nice. Import. Very nice. You're gonna see some things here, and this is because I sped through that import pop-up. There's like a checkbox normally that says import materials. And if you don't click it, it's not going to generate the materials based on what it thinks you wanted from Blender, but it should generate them here. It's taking it a second, probably because the text in that model has a lot going on it, and it's also generating distance fields and the nanite stuff for it, presumably. Here we go. So there it is. Nice. There's our building. Very cool. Very cool. And Unreal Engine, looking pretty good already, pretty snazzy. The colors are somewhat preserved here, and you're thinking like, oh, that's interesting. Yes it is. I'm gonna delete all of these materials that got imported. I don't really care. So bang, goodbye, force delete because they're attached to the asset, and delete the windows as well. What matters is the fact that this test model, I double clicked it right now to open it up, has these slots right here, material slots. See that? That's what's important. Right? If I click highlight, right, or isolate, ooh, nice, yeah, there. You can see what different surfaces are made up of different materials. So this, oh, and they have slot names too, that's so great. So that's really important for us. That's how we then go in and define our own materials. Let's go ahead and save this. All right. So back to the PowerPoint here. That's how we import materials into Unreal Engine, and then we can actually go in and individually texture all of those surfaces. I'm going to go ahead and speed through that as well. I'm going to make a material, and I'm going to call this master material. We're going to get back to this in a second. Actually, I changed my mind. So master material, you'll see what that is in a sec. So today, let's move on for a second. We now know how material slots go from Blender to Unreal Engine. Let's talk a little bit about some other important nodes. LERP. LERP is a really important node. It stands for linear interpolate. It's so important that it has its own keybind. When you press L and you click, you spawn a LERP node. Here's an example of a really simple shader. I don't want you to stress out about what these nodes do. I do want you to understand that we have a texture here and a texture here. Forget this stuff. This is about the alignment of this texture. Don't worry about it. Just imagine we got Phil Swift and Billy Mays. So we're going to do a LERP, and there's A, B, and alpha. And we have this parameter right here that we can scroll from 0 to 1. So as we change this parameter from 0 to positive values, it transitions to the other thing. If it's below 0 or above 1, you get undefined behavior. That's why we're seeing this like crazy JPEGing of the image. But that's what LERP is. It's very simple. If the alpha value is 1, spit out B. If the alpha value is 0, spit out A. If it's 0.5, output half and half. Yeah. The creme de la creme, material instancing. So let's talk about what material instancing is. This is what I'm about to demonstrate with a master material. There's something called a draw call in 3D rendering, and it's your graphics card saying, oh no, I need to fetch data from like the CPU, from memory. Draw calls are really bad. Every draw call creates a little bit of lag. There's usually several 100,000 draw calls potentially in an environment, but it is our goal as game developers to keep these low. Um, so draw calls cost precious nanoseconds. Each material that you make that is visible to the user is another draw call. To reduce draw calls, we instance the material. This also lets us do more. Observe. So let's see what I mean here. We have a material here called master material, and what I'm going to do is I'm going to create a color property, right? Just like that. But I'm going to do something else. I'm going to keep this as 0, 0, 0, and I'm going to right-click it, and I'm going to do convert to parameter. And what this is doing is it's saying any instances of this material will have this property exposed to be adjusted at a later time. And I'm going to name this base color. Hit save and apply. And then when I go back to my main screen, I've got my master material here. I'm going to right-click it and do create material instance. And now that we have this material instance, it is a copy of this material, except the only things that we can adjust are the properties that we exposed, like base color. I could have named that anything. Here's the cool part. I can change this in real time, and it updates in real time. I don't have to wait for it to recompile, which if you're on a slightly slower computer, takes a few seconds. I can just play with the values and they instantly update. Better yet, you can attach code to this. You can say, as my character takes damage, decrease their, desaturate their skin color or something. I don't know. Make them redder. Make them flash red when they take damage. You can do all of this using material instances. You cannot do this on a master material. So the general practice here is to use material instances as much as possible. There's more advantages than that. Here's our test model. Let's go ahead and fill it up with a bunch of material instances. I'm going to make this into a second little tab like that. And I'm going to name this instance door. I'm going to copy paste it. I'm going to name this instance awning red. I'm going to copy paste it. Name this instance awning white. Whoop. Okay, whatever. Awning white. Sure. And awning white can actually be white. Let's desaturate that. Bang. Cool. Plug that into, is it that one? Did I guess right? Yeah, I did not. It's the next one, isn't it? Yeah. And then awning red can be this guy. So we're sort of plugging in these materials into the slots. Door is the last one. Building is going to be another one. Come on. Building is going to be the first one, I think. What are these? One of these is the text, the windows, right? Let's do the windows. So for the windows are like a fundamentally, I mean, the awning is a good example. Actually, the text, sorry. Yeah, I'll keep going. Door, here's another one. Windows, and then glowing text. Sorry, I'm not making a new one, just keeping new material instances. So these are all instances of the same material, which means that they all together cost a single draw call. I don't care how many instances of the same material you have on your screen, one draw call. So that's just a thing that you want to optimize and reduce. We'll call this neon. Okay, now each of these only has like one property exposed. I'm going to close all these tabs. However, we can keep adding more to them. For instance, back in the master material, we can add another property called emissive color. And I'm going to make this a parameter, emissive color. And, I'm going to also multiply it by another parameter. So how did I spawn in this multiply? M, another keybind. But you can also just right click and look up multiply, and it pulls in this multiply node. So I'm going to multiply this color value by another parameter, and I'm going to name this emissive emissive strength. And now all of our materials, every single instance now has that as like an option on it. So for instance, if I click on door over here, I can check these to say I want to edit them. I can say emissive strength 100 and emissive color green. And now we're glowing like crazy. And so are our doors. Look at that. Yeah, pretty sick. But we don't want that here, so I'm going to go ahead and uncheck those and make the base color this dark brown kind of color. Let's see. Yeah, I like that. Nice. There's our doors. Beautiful. Let's click on the building. Let's make this guy more of a concrete gray kind of color. I like that. Develop Cafe. The windows, I want the windows to be black. And I also want them to be shiny. So we'll do that in a minute. But yeah, it's coming together. Red awning. Kind of want that to be red. Nice. What am I doing? Why is it orange? It's orange, even though we're kind of red over here, because it's the sRGB preview. That's right. Let's actually focus what it looks like in our world. Feels like red is right around here. That's good. Cool. Okay. There we go. All right, I'm happy with these materials. Where's the... Oh, I forgot to attach the neon text. Where's the neon text? Neon. Let's grab the neon over here, change the emissive strength to like 10, and the emissive color to green. You'll notice that emissive kind of just completely overrides base color, but there is a subtle difference, so I'm going to keep the base color to a nice green or so, maybe like a white. It doesn't really matter. That's a little too bright for me. I'll turn it down a little bit. And we got the Develop Cafe. Yeah. Beautiful. Nice. All right. Back in our world. Here's our building on this kind of ugly terrain. I'm going to make the ground be more of a white value. There we go. Save and apply that. Notice we don't have to save and apply when we do all those little materials, but we do now. And we're getting this green glow on the ground too, which is courtesy of Lumen and the software ray tracing that Unreal does, so that's really cool. But yeah, there we go. We got our building now. Okay, brilliant. Yeah, material instances. So here's the magic of material instances. They let us expose specific vectors and textures to be edited at runtime. However, you can do some really cool magic with them. What if there's weather in your game? What if there's a time when like every object in your game should get wet, or every object in your game should get snowy? You can expose properties on the material, and every material instance will have that property available. You can even use something called a material parameter collection to have like a global value that gets shared across all of your material instances. For example, a global is it snowing value, or a how much snow value. And from that how much snow value, you can build up some snow on the surface of an object. So I'm going to try to do a demonstration of snow in a second here. Yeah, how do you expose values, right? You right click on all sorts of nodes support this. Just right click on a node and do convert to parameter. You can make textures be a parameter, so you can swap out the textures of a material, and it can all be part of the same material. So just different instances. Yeah, materials, they take forever to apply and see the results. You can't edit a material at runtime while the game is running. It costs a draw call for every material in your object. You should only make new materials for really special use cases. For instance, if you have a water material that has all of this really complicated code about how to render water, that code should probably not live adjacent to code that's just this really simple like wall surface. The wall could be part of the master material that your whole game revolves around, but the ocean is this really dramatically, fundamentally different thing where there's water in waves and it moves around, and snow does not build up on its surface. You guys understand? Like if you have really dramatically different functionality, keep it separate. Instances share the same draw call as their parent material, so the CPU gets to relax. You should use instances absolutely everywhere you can. Okay. Master material is a common word. Master material is just a material that has a many settings exposed so you can make a bunch of reusable instances of it and put it into your world. Let's go ahead and take a look at textures for a second. All I'm going to do, I'm not going to wholly explain textures, but I'm moving quickly here to try to make this as viable as possible for the 1 hour time that we have. I'm going to add a switch. Excuse me. Feature switch. It's a static switch parameter. That's what I was looking for. I'm going to name this use texture. This is a parameter. And if use texture is false, it's going to use the color. But if it's true, let's use a texture. So I'm just going to click T and click. You can also just right click and do texture and hit enter. And it just generates a texture sample. And this texture sample can be anything, but any texture. Let's go ahead and import a texture to our environment. I'm thinking for the building, we're going to do like a nice concrete effect. So I'm going to look up concrete seamless texture. Seamless is to say that it has a left and right side, right? Polished concrete, sick, small, don't care, that's fine. Great, it's on my desktop now. I'm gonna go ahead and drag it into Unreal. Bang, there we go, dragged it in. Some issues with the import. No, say it ain't so. Let's try that again. Failed to re-import. Bro, where is it? That's funny. Real quick question so make it so I can understand. If you have one material with a parameter and have two meshes use that material, but with a different value in the parameter, that would be one draw call. That would be one draw call, Dion. So yeah, you have like here. Let's make a copy of our building. Different static mesh over here. We can give it the neon value for. We can make another door instance, even door 1, and this version of our building can have bright orange doors. Two different buildings, bunch of different material instances, but this guy and this guy are only generating 3 draw calls, I think. It should be 2 draw calls. It should be 2 draw calls. One for the mesh, which these are 2 instances of the same mesh, and one for the master material, which all of their instances are being sourced from. Yeah, 2 draw calls. I'm 99% sure on that. Okay, sorry. I was gonna do a texture, and the concrete texture that I found is not playing nicely. Let's just go to Google Images. Usually there's some great stuff right here. Concrete, polished, seamless. We could even have the iStock watermark in there. Here, save image, desktop, save, great. Drag it in. Hopefully this one imports. This one imported. I don't know why the other one didn't, but it doesn't really matter. Back to master material. Let's also convert this to a parameter, and we'll call this texture. Save and apply. And now, if we wanted to, we could make our windows be made of concrete, or the building. So here's the building 1. Here's the building instance. I can check the use texture box. And when I do, the base color parameter disappears and we get this texture parameter. I click the texture, I hit save. It's a little angry. It's a little more than angry. Why are you angry? Coordinate, save, apply. Usually this is exactly how things work. Building, texture. Texture sample param2d found null requires texture 2d. I suspect that it wants a texture object. Hold on. Texture object, convert to parameter. There we go. Excuse me. There we go. Back to, excuse me guys, 1 second. Back to building, texture, Cannot force a cast between non-numeric types. Oh god. Oh god. Sample. Like so. Yes. Yes. Okay, there we go. I'm sorry. All right. Now, the texture is really stretched on most of the surfaces here. And that's because we never UV unwrapped it in Blender, but that's okay. Now our building has a bit of a concrete texture. It's really subtle, but I can see it. You see those kind of splotches there? Yeah. Cool. So that's how textures work. We're almost out of time for this little, speed run of shaders, but this should give you everything that you need to make a basic shader for your game. Make materials and apply them to the surfaces of objects, and you can very quickly, have some higher quality objects put together that actually, look a little bit better than this building that I threw together in the span of a few seconds here. Yeah, I'm going to really quickly just speedrun the end of the presentation and demonstrate dot products and snow. So here's an example of a master material. You can have these texture objects, texture samples, plug them into the different properties, and then every material instance can have those exposed as options. You can expose a scaling parameter. So if I was to do that right now, I could go in here and do, in the master material, I could make a, texture coordinate, and I can divide this by texture scale. I'll make a one vector parameter, and I'm going to name this scale, and the default value will be 1. Save and apply. And then when I go back to my building material, like so, I can change scale, crank this up, and we get a really small repeating texture on the surface. I don't know how clearly you guys can see that, but on the building here, we now have an actual concrete material that's a lot smaller and finer on the surface of our object. It actually looks pretty nice. Some splotches there. I like that. Cool. Not bad. Not bad. So that's how you apply a texture to a surface. Moving through this a little bit more. Let's add snow. Yeah, so dot products. Do you guys know what dot products are? Who's taking Calculus 3? Someone. Maybe. Doesn't matter. I'm going to teach you. Dot products are really simple. Think of them as a function that takes in two vectors and it finds the angle between them. It does more than that, but if the vectors are normalized, they have a length of 1, then you can take the dot product between them and you find the cosine of the angle between them. Here is the surface of a sphere. Here's a light source vector. The light source vector hits the surface over here, and we get values of 1. We get this brightness. Around the hemisphere, on the equator, relative to the light source, we see 0. And on the back of the sphere, we were going to get values like -1. This is if we take the surface of the sphere and we dot it with the inverse of the light vector. So this is sort of saying, how much do two vectors agree? If two vectors are pointing in the same direction, 1. If they're pointing in opposite directions, -1. If they are orthogonal to each other, 0. So that's dot products. There's normals. Normals are the lines that run orthogonal to every surface. The hairs on the surface of this sphere represent the normals of each face. The pink ones are vertex normals, so they're sort of the average of the surrounding faces. But the blue ones are they're just lines that come straight up and out of a surface. You can get the vertex normals in Unreal Engine. You just spawn in a node like vertex normal, and you get the vertex normals in world space of an object. Well, snow accumulates on the top of an object. So what you can do is you can say, hey, where the vertex normals agree with the up vector, where their dot product with the up vector is 1, put snow. And everywhere else, don't put snow. So again, it just finds the angles between two vectors. Here's an example of a snow shader doing its job. This is an object, some rocks. You can spin it around. Doesn't matter. Snow always accumulates on the top facing surfaces. You can do the same effect for moss. You can do the same effect in a more complex way for water. You can say water should go down the sides of surfaces, but just puddle or form raindrop effects on the tops of surfaces. So you can sort of do mapping like this very easily. And if you have a master material and you've been doing things right, then your whole world is referencing one big master material. So all it takes is like very little work on your part to say, let me add a snow feature to my master material. And you do a handful of little nodes, and a second later you have a slider that you can drag and add snow to your entire world, which I think is awesome. It's very easy to do that. So I'm going to demonstrate that super fast. We got this the building over here. I'm going to go to master material, and what I'm going to do is I'm going to say the base color. Remember the LERP node, guys? We're going to switch between the whatever is going into base color and some snow value. Let's say the snow color should be pretty universal, so I'm not going to expose it as a parameter. Snow is white, last I checked, unless your dog used the restroom in it. Maybe it's not white anymore after that. And the alpha value, this should be 0 to 1. So just for starters, I'm going to clamp the input between 0 and 1. This is a clamp node. And I'm going to do the dot product of the vertex normal. What? Not vertex color. Vertex color is a different property. Vertex normal. WS means world space. So here's the vertex normals. And the up vector, which is going to be a 3-dimensional vector that is pointing up. And what we should get, the beautiful part about nodes is that you can just visualize things. Like if you're not sure, you just plug this into base color instead, and now we can see the effect that that's having. Here we go. We got white only on up-facing surfaces. Great. If we raise this to a power, right? Power of 2, we sharpen the snow. If we raise it to power 3, we get the sharper near the top. We raise it to a power of 10. And the reason why is because values that are like 0.5, 0.5 to the 10th approaches 0. However, 0.9 to the 10th hovers around 0.9, 0.8. So what we're doing is we're taking these 0 to 1 values that run from the equator to the top, and we're taking the values that are like lower, and they're flattening them out, and we're only keeping the sharp ones near the top. Let's go ahead and make this like 3. I like that effect. We'll plug that back into LERP, base color, bada beam, bada boom. Oh, these are backwards. We're gonna want to flip these. So A, B, there we go. And now, whatever is normally going into base color applies for the sides. Cool. Okay, the top facing surfaces of our building are now snowy. And to visualize that a bit better, you can see that all of our materials just updated. Look at that, right? The awning is now building up some snow on its surface. Sorry, you guys can see that right there. Yeah. So let's go ahead and I'm gonna move on to rigging in just a second, but I love this stuff. I'm also going to use this same stuff right here. So I'm gonna call this all these nodes. I'm gonna move them to the side like this. I'm gonna press C to comment them out, and I'm gonna do snow mask. So now we can reuse this, and we know what this is doing. We know what that's doing. And then all of this is going to be our incoming base color. We can also give an individual comment to this node. We can say snow color. And this snow mask, let's make this a little bit prettier because we're going to reuse it in a couple of different places. We can reroute. And this node lets us move it around. So we can say, we can call this snow mask. And now, anywhere else in our code that we want to, we can just type snow mask and reference, this is like a portal. Like stuff goes in here, comes out of here. And we can reuse this in a few different places. So we can say, based on the snow mask, go between our usual roughness value and some snow value. So I'm gonna go ahead and lerp down here as well. And I'm gonna say, based on the snow, if there is snow, the roughness of snow should be like, I don't know, 0.2, kind of shiny. Otherwise, make it 1. That's actually backwards, so I'm gonna make this 0 and 1. There we go. Snow is definitely not metallic, so I'm going to use this again for metallic, and I'm gonna plug that into the alpha. I'm gonna say for metallic, Snow has a metallicity value of 0. Otherwise, it's also going to be 0, but this should be our metallic parameters. So maybe we have this thing here that says metallicity or metallic. And this should be a Boolean, honestly. So I'm going to look up Boolean instead. Or, ooh, switch. Yeah, it's a Boolean value. I'm just going to, here. There is a way to do Booleans, but for the sake of time. Metallic. Great. And now, let's say, let's go back. Our snow is now kind of shiny. It's difficult to see because I made the building white. Let's go ahead and make the building not white. Let's make it not use the texture, and let's make the color value of the building be more of a cream kind of value, like all those modern developments are. There we go. Now there's snow accumulating on the top surfaces. I like that. What a vibe. It's like a little snowy vibe. We got snow accumulating on the top there. Now, I'm going to even take this a step further. And we can do tessellation. We're almost done here. So I'm going to go over here and look up tessellation. Nanite. I know this is a new feature. Displacement. Oh god. Okay, I'm going to check use with nanite. Not done this before, but I suspect that nanite should allow us to displace based on snow. So what we can do is we can say displacement. No, not displacement, sorry. We have an up vector, right? Okay, here's an up vector. And we want to move the surfaces up if there is snow. So the world position offset, we're going to make this be some value for of snow buildup. So the snow buildup, I'm gonna make a parameter for it called snow buildup, and this is going to be how strong the up vector is that we're going to apply to the surface, but we're only going to apply it to surfaces that have snow, like so. And now you guys can see what this does real quick. Let's go to one of these materials. Oh boy. Here's the building material. Here is the snow buildup value. Watch what happens when I crank this up. Wow. Yeah? See, ooh, that's a lot of snow. That's a lot of snow. Alright, go back to our building. Oh yeah. The snow has moved the top surface of the building up here. Yeah. So let's probably tweak that down a little bit. Pull that to the side. Put this over here. Turn this down. A little bit of snow. There we go. So the thing is, it's sort of detaching from the surface of the building, and you're thinking that's not good. I agree with you. There's a tessellation solution to this, but I don't know what the implementation is. There's a way to do nanite on structures like this in such a way that it actually, subdivides it appropriately and makes the geometry move around in a perfectly healthy and sane manner. But I'm not sure what subdivide. Yeah, I don't know exactly how to do it, but there's a tweak somewhere that increases the amount of geometry at our disposal and makes things move around. Great. All right, that has been materials. I hope this was insightful. The cool part about this, by the way, is that the snow mask does change depending on how you rotate something. So if you were ever making rocks or barrels and you had them upside down, the upwards facing surfaces are always what's going to accumulate snow. Resource recommendations for learning about nanite. Nanite, there's not much to learn about it. It's just a feature of Unreal Engine. If you want to actually learn how it works, you got to read some research papers. In terms of resource recommendations for shaders, yeah, I will drop those momentarily. So I know someone asked about dielectric materials and why they have optical properties different from conductors. there's just something to do with anisotropy. Anisotropy is like the directionality of a surface. Um, uh, yeah. Um, I'm I'll drop some info on that in terms of actual shader skills. I'm going to drop you guys this flowchart right here, which kind of gives you an idea of like what you should learn about in what order, right? If you learn about how emissivity works, you can make your material glow. If you can make your material glow, you can also learn how to make your textures glow, and so on and so forth. Once you make a master material, you can start doing these things. Once you start doing these things, you can do more magic. It's like a nice little convenient flowchart. It also shows you how to make an ocean shader or how to make a grass shader. Grass and ocean shaders are like the cream of of making any shader. Like water and foliage are often very complex and very interesting challenges that require a combination of like waves and sine waves and like the time value. There's a lot going on in them usually. So, uh, but yeah, um, yeah, yeah. That's I'm gonna take a quick break here and try to answer questions. I know we moved through that really quickly, but it was only an hour this time, hour 10 minutes roughly. So yeah. What's up, guys? Let's talk. Unmute. How's it going? Do we like that feedback?
Hello.
Concerns? Yo, Mike, is that you?
Yeah.
Yo, how's it going?
At the start, I mentioned this in the like voice call one, but I had a lot of issues with OpenGL a couple nights ago.
Oh yeah.
A lot of hours of trying to get it working on my old computer.
Oh, I got you.
So you brought horror back to my.
I'm sorry. It's annoying. It's annoying. That's why. But once you get a graphics library working, it works with AMD. It works with NVIDIA. You can just sort of make it work anywhere, which is very nice. Um. Yeah. Can I? I mean, any questions, guys? Any like interest at all? Any curiosity? Um. Shaders. I'll say this as well. So the PowerPoint today that we burned through right here. Um. I have another handful of slides from slide 119. Anything with a black background we skipped over today, but there's around 40 slides for you that very slowly walk you through the different parts of an ocean shader. I've even got a Desmos link that explains some of the math of a Gerstner wave and how you can like yeah, so that's kind of cool. Um, Parametric Gerstner wave and then all the way up to like stacking them together, but we're not gonna. I don't stack them in this. But yeah, just ocean water. You can make this shader right here. It's very easy to do. It's not that bad at all. It's just a handful of nodes. But yeah, yeah. I'll also drop the blend file. In fact, I'm gonna take the next few seconds to upload things while people ponder their questions. I see a lot of people sticking around, which is like unsettling because I've warned against trying to watch 4 hours of workshops in one go. But more power to you guys. Just if you feel tired by the end, that's not on me. I told you to watch one at a time.
Actually, I have a question about that. So
yeah,
is the programming one 2 hours long then?
yeah.
Okay.
I
need
wanted
to
to
change the
take
announcement then.
I wanted to take more time with that one.
Yeah.
Yeah. Yeah. Based on the when to meet, people said they were most available from 4 to 8, so that's what I went with.
I am probably leaving now to go eat, so I can be ready for that one.
Nice, cool. Yeah, I'm gonna try to speed run through rigging in the next. God, rigging is only gonna be 30 minutes, I guess. Are you guys really waiting here for rigging?
I'm here all day.
Oh my
I
god.
joined a couple minutes ago for rigging.
Say again, J Red. What was that?
I just joined for rigging.
You just joined for rigging. Perfect. We're gonna get started in a second. I'm sorry, I know we're a little tiny bit behind schedule here, but I'm still recording for the shaders just to answer any straggler questions or curiosity.
No, I caught the end. It was great. Great job.
Oh, cool, cool. Thank you. I'm glad you liked it.
I'll be back.
Okay. Okay. Yeah, no worries. Yeah. Okay. All right. Great. Yeah, I'll go ahead and close down Unreal Engine. Save this. close the engine, save it. I'm going to share the slideshow with people that have a link. Oh boy, commenter. Here you go, guys. And I'm gonna go ahead and I'm gonna keep recording in case anyone has any questions. Link to PowerPoint is right here. Additionally, share this PDF. Anyone with the link can comment. Link to PowerPoint, link to skill tree. There we go. And I'll drop a link to the video at a later time. But yeah, cool. Great stuff, guys. If you make anything with shaders, share it. Use our bot. Put it on the website. There's some cool new features on the website. Styling is changing. There's more editor tools. Yeah, you guys should definitely check out the site. Here's a shader. There's a shader that's running on this laptop here. It's being rendered, but it's also doing a bloom shader that's making it glow. So glowing is a shader. It's downsampling the image a billion times, blurring it, and then scaling it back up, and splatting it out onto the original image. So called a Kawase blur. Cool. All right. I'm going to wrap it up and I'm going to try to speed run through rigging. Oh, I'm going to also upload the Blender file to the shaders post so I don't have to do that later. Let's upload the file from desktop. Test model blend. All right. Cool. Okay. I'm gonna stop recording.